All right, hello everyone. So this is the video solutions to the Monday, April 6th worksheet. And in the first question, you're asked to rank the strength of the nucleophile or Lewis base. And remember, very often the strength of a nucleophile and the strength of a Bronsted base or acid, Bronsted base go hand in hand. So if we look at these things here, these are the anions, or the conjugate bases in the Bronsted sense, from the acids that would have had the H's there. So that's really what we need to go on here, because again, strength of nucleophile and strength of base typically go hand in hand. So this would be the weakest acid if there was an H there. So this is going to be the strongest base. And then we have the oxygen and the nitrogen. Again, the oxygen still quite weak. That would be ethanol. pKa would be 16 for the acid. But of these, that's actually the weakest, which is a little bit odd, because typically we would even consider that ethoxide to be strong. We would call it that. But again, of these three, it's the weakest, and then this would be the middle. So once again, the strength of a nucleophile and the strength of a base, right, Lewis base, typically go hand in hand with the strength of the Bronsted base as well. Okay, so there's that one. Now the bottom one, this is going to be quite similar to what we did the other day as well. We're looking for the arrows, right, to show the electron movement. So now we're completely in the Lewis here, right, arrows and electron movement. And we want to know which is the nucleophile and electrophile and if they're strong or weak. Okay, so this one right here has the electrons. It's going to, oops, let me do that in red like I did the other day again. It's going to use those electrons to form a bond to the hydrogen to make the water molecule. So that arrow makes this bond here to form the water molecule, and then the pair of electrons from this bond stay behind as a lone pair on this O to become O minus. Okay, this thing has the electrons. So that is the nucleophile. This is where the electrons go. That's the electrophile. And again, OH minus, that is a strong base, so we would call that a strong nucleophile. And this one, it's sort of moderate. I would call it weaker, though it's not nearly as strong as that, so I would call this weak. Okay, now again, those sorts of carboxylic acids for the organic molecules are strong, but in the biggest sense, they're relatively weak. Okay, but this strong nucleophile really is the key to the whole thing right there. Okay, and now we've got 3 or 4 more also to do for this question number 2. So I'll erase these and then we'll do a couple of more. Okay, so the next one, let me just get it here. Yes, okay, so this one is again hydroxide, but now this time reacting with iodomethane or methyl iodide. Okay, and here we're going to have methanol and I minus. Okay, so once again, this has the electrons, so we are going to use those electrons to form a bond to the carbon. So that's this CO bond right here. But in order to do that, we need to break the bond between the C and the I and put those electrons as a lone pair on the iodide. So that would be the 4th lone pair right here. Because again, carbon can only have a maximum of 4 bonds. So we cannot form this one without also breaking that one. Once again, this has the electrons. That's the nucleophile. This carbon is where they're going. That's the electrophile. This one is definitely strong. And a carbon now of this is absolutely weak. In fact, it's much weaker even than the one in the previous example, because here it's just the polarity of the CI bond that makes that an electrophile. So that one's actually quite weak. Okay, so for the next one, once again, we have hydroxide. So are we noticing a theme here? Right, so we have HO minus, and then we have an H, CH2, carbon, CH3, CH3, chlorine. And after this reaction is done, we have a water, a Cl minus, and then this alkene. So we've actually changed the functional group in the molecule. Well, once again, here's our thing with electrons, so that's our nucleophile, and it's strong. Okay, so are we noticing a theme here? Now, what's the electrophile? Well, let's look. This OH has a second hydrogen bonded to it. So this H is actually the electrophile. And that is very weak. And in fact, it's even weaker than the previous. So we're getting weaker and weaker and weaker here with our electrophiles. But we have a strong nucleophile in each case. Okay, so once again, this one is going to use a pair of electrons to form a bond to the H. So that's going to be this OH bond. But hydrogen can't have two bonds, right? Maximum of 2 electrons. So we're then going to use this pair of electrons to form our alkene. So this alkene comes from this pair of electrons, but that carbon already has 4 bonds. Oops, I forgot some electrons here. Okay, so in order for that bond to form, we need to break this bond, and that needs to become a lone pair on the chlorine. So that's a whole series of electrons moving. We start with the strong nucleophile, form a bond to our weak electrophile, move a pair of electrons to make the alkene, and then Cl minus leaves. So that one's a little more complicated than some of the previous ones, but the same principles apply as we've used for all the others. Okay, and then one last one. And this one's going to be a little bit different. So we've noticed the strong nucleophile and whatnot in all of them. Now for this one, we're going to have a carbon with a CH3, a CH3, a CH3, and a positive charge. Okay, and we've got this. So let's look at this one now. Well, the only thing with any electrons on it is this oxygen on the water molecule, right? So that has to be our nucleophile. But now that's a neutral molecule. Water is a perfectly happy, stable molecule. So that is not strong. It doesn't really want to do anything particularly, but you can make it do something if it really needs to. So this is going to be a weak nucleophile. It's a neutral molecule that's perfectly stable and happy. But this carbon with the plus charge, that's our electrophile, and that is a very strong electrophile. So I wouldn't even say strong, I would probably say very strong there. So this water doesn't especially want to do anything. It's a neutral, stable, happy molecule, but because of the strength of this electrophile, it will react. And so in this case, there's simply one arrow. That pair of electrons from the oxygen on the water forms a bond to the carbon. And in doing so, this carbon now has its 4 bonds.